here's our opening problem. Hopefully you looked at this and thought, oh, this is fairly simple. I wanted to discuss a few things with you about this. Number one, writing out your zeros here is not really complicated at all. You're looking at this. This is almost all already factored for you. So if we do factor it, what we can find out is just going to be x. It'll be x on the outside times x minus 3. And that's really two different times. So it's going to be x minus 3 also. And so this is all, of course, equal to 0. When you find zeros, basically that's exactly what I'm trying to get you to think about. What if I set this equal to 0? What would cause this to become that? And so if we look at it this way, we would get x equals 0. That's the first part. Then we have x equals positive 3. And then x equals positive 3 again. So we have three different zeros. However, two of them repeat themselves. Or there's one that has what we call a multiplicity of 2. And so if you were to write this as a solution, one of the ways to do that, you could write it as you see on the screen, or it would be x equals 0 would be 1. And then, of course, you could write x equals 3 with, I abbreviate it MUL, multiplicity of 2, which means that 3 occurs twice. I don't know that you've heard that or you've been aware of that, but what I want to definitely make sure is that you've seen that before. Using the term multiplicity, I will use it several times. You'll see it on quizzes and tests and things like that. Very simple, nothing really complicated to really go with. But if you have things that occur more than one time, then you're going to have a multiplicity. And I want you to comment on that. Or if I write that down, I want you to know what I'm talking about. Graphically, if you were to graph this equation, what you would see is that you would see that the equation would touch the positive x-axis or negative x-axis some way. If we go over and we look at this graph, what we'll see is we'll see the 0 definitely happen at our 0, but at 3 you're going to see it's going to come down and it's going to touch the x-axis only in one spot. So we have x times x minus 3 squared. And so we'll go ahead and graph that. Let's reset our zoom 6. So there it goes through, and then immediately you can see that it goes through 0. That's easy. And you can see that it touches the x-axis. I'm like, well, does it actually touch the x-axis, or is it fooling my eyes? Well, I can go over here to my table. If you want to look at that, press second and graph, you get your table, and I can see that 3, 0 actually is one of my zeros. Well, because it only touches the x-axis, it means that I'm going to have a multiplicity at that point, which is why that we have 2 zeros at 3. Welcome to Pre-Calculus, Day 2 of Section 3. Obviously, I'm not there, but fortunately for you, I'm still here, sort of. So I want to start off looking at one of the things that we left the class with on Friday. I talked to you, or I showed you this equation, and I wanted you to graph in your calculators, and there's a couple of reasons for that. Number one, go ahead and type this in your calculator as I'm kind of going through this. What I want you to do is to graph this. This example is really to show you that sometimes you can't trust your eyes because of what the calculator screen looks like. We have to take a closer look, and I want to show you that. I want to show you a little bit of zoom, a little bit of maximum, minimum. So this is kind of a calculator tutorial. You'll see that a couple of features as we go through today's lesson. But if you graph this, you're going to look at it, and it's going to appear as if it looks like it has only three zeros. But if you look at the degree, you can see here it has a 4th power. That is my degree. The degree of an equation always tells you how many zeros that you are going to have, or how many possible zeros you could have. In this case, we should have 4. However, we could end up having some of them be imaginary, which would mean that they won't actually cross the x-axis, so you may only see 2 zeros. Okay, you may have 2 imaginary roots as well. And so we're going to look at this equation. I'm going to kind of show you the result, and then I'm going to go through it with you through the calculator. So at this point, hopefully you've got this graphed. If you do have it graphed, you should see this picture on the left. If not, then make sure you reset your zoom. Remember, always reset your zoom by going zoom 6 or zoom standard. That'll put your screen back to normal. You look at this one, it looks like it goes through the x-axis here, and then once more here, and it looks like it touches the x-axis and goes back up to give us 1, 2, and then only 3. But if we zoom in just on this little section right here, that's what it looks like. So you can see the picture on the right where it looks clearly, it goes up through the x-axis and then back down once and back up to give us our 4th time. So let's go ahead and look at the calculator and see what this looks like. So if we go back, go to y equals, notice I have 3 equations graphed. But if you look down at this bottom screen down here, I actually only have 1 graph on my screen at the same time. If you look over here, you can tell next to the equal sign, I do not have a black box around anything but the y2. So this is what we can do. To activate an equation, if you have it in there and you don't want to graph it all at the same time because you want to keep it there but you want to only look at one of them at a time, you turn on and off your equal sign. So it's kind of like activating and deactivating your function. So I move my cursor back to the left one time so that it's blinking over the equal sign. I'm going to hit enter, and now the black box is permanent on that. All right, I want to turn this one off, so I'm going to hit enter, and now you can see that the only one that I have graphed, or the only one I have active, is y1. So if we were to go to say graph, then it's going to show us only the one that we have selected, and you can see that there. And this is the exact example or the picture we showed earlier where it looked like it only had 3 zeros. So here you can see the screen. You can see the this is your, if you were to press second and graph, there's table. You would see your y1 and your x's and y's for that particular function. Even looking at the graph as well as your x and y values, it does not look like it would pass back through because my x values are in whole numbers. So we need a closer look. So the way that you can examine something, and I think we've looked at this before, but let's go again. To zoom in on a particular section of my graph, I'm going to press just press zoom. So press zoom. There we go. And I want to use box, the Z box. So I'm going to press 1. That was Z, or that was zoom and 1. And I want to make a box around that little section. So I move the cursor, and this is the way that I like to do it. I go and put the bottom left side of the box down first. So I go just below the x-axis a little bit. I hit enter to put the corner down. And then I'm going to go up just a little bit so I can get above that part of the of the graph. And then I'm going to go across so that I can make sure to include all of those little pieces right there. And so once I see that I've got all that little section within that little box, I'm going to press enter. And it's going to zoom in on just that little section. And here we can clearly see that the zeros are in fact on my graph. Now, little tutorial about zeros. If I wanted to find these 3 zeros, they're clearly not going to be whole numbers. In fact, they're probably either irrational or just some nasty decimal. So the way to find zeros, and if I'm going fast, you can't write all this down, no worries. This is on the website. You can go back and watch it and write down whatever you need to write down later on. So to find a zero, you press second, trace, or the calculate feature, and that brings you to 0, minimum, maximum, and several other things. We wanted 0, so I'm going to press 2. Now, the way that all of these features work, the calculator sees the graph as one big set of numbers, really, and it's asking for a left bound. So what it's telling you to do is, okay, go across your graph, and I want you to mark off a section to look at. So we're going to mark the left endpoint, so here, And then I'm going to go past the section that I'm interested in. So here, that's pretty much where the 0 is. I'm going to go past that point just a little bit and press enter. So now I've got two sections. I've got this one, and I want to find the 0 within these two lines. That's right. So it's right about there. So it's asking you to guess at it. So you're going to get relatively close. There's only one in this section. If there had been two within the same section, I would have to be very specific about when I picked the guess point. At this point, there's only one 0. It's going to find it no matter where you click. So I'll click enter. And this one turns out to be fairly nice. It's 1/2 or 0.5 comma 0. To find the other two, we'd repeat that process. Let's go back to second trace, and it resets. You'll have to do it all over again. 2, or you could have just pressed down and enter. So I'm going to hold and scroll over to this part. Now notice there are 2 in this really close together, so I'm going to be real careful in the way I pick my left bound and my right bound. So as I go past it, I'll hit enter, and then just get back a little bit. That's close enough. Turns out the next one is 1.133 comma 0. And then we'll do the third one real quickly. Second trace 2. Gonna go down. That's close enough. Enter. Keep scrolling across. Go past the 0. Then scroll back to about the same spot and hit enter again. And this is going to be 1.367 comma 0. So that's a really quick way. If you were to look at a problem like the one we have here, which is really, really ugly. It's got a lot of decimals. It's not meant for us to factor or anything like that. If you were to take apart this equation, you would need your calculator and to do that with. So that's how you find zeros. Okay? And that was not exactly what the equation was about, or the question was about. The question was really looking at, are you aware that sometimes the calculator, the way it looks, is deceiving? So be very careful about those things. All right, I want to go on a couple of questions about your homework. If you guys need to pause this, if I'm going too fast, or you even want to rewind it, hey, can we watch that part again? Please just speak up and let the sub know that you want to do that. Okay, so we're going to look at a couple of examples. This is kind of where I wanted to go on Friday, but we ran out of time in class. So number 53, this one's kind of straightforward. I want to talk about that one for just a little bit. 53 looks at, let's do this. Don't want to give 56 away just yet. All right, so what this one's asking you to do, it's got 3 roots. It has 3 zeros, and it wants you to look at these zeros, and I want you to give me the equation that it started with. So imagine this is factoring backwards. I'm giving you the result, and I want to know what I started with. And so you always say x equals 3, x equals -4, x equals 6. And so you rewrite those as factors. Remember on Friday, I made a real big point to talk about what were roots or zeros, and then what is a factor. And so they're very different in the way that they look. And so we have x minus 3. It's just x minus whatever you had up top. X minus -4, that's why it turns to plus, then x minus 6. In this particular case, you have no terms that seemingly stand out to you. They're all very similar, and they're just x minus a number. And so I can choose any 2 to multiply together. So I simply chose the first 2. X squared plus x minus 12 is what I get when I multiply the first 2 together. And then I'm going to take the last one, bring it down, and multiply that using the distributive property. And then I have my solution. No big deal. Okay? However, if we look over at number 56, this one tends to be a little bit uglier. Remember, if you need to pause this, pause it. I may be going a little too fast. Number 56 has radicals in it. Now, I had written on the board, or on the screen, I had actually only written the first 2 roots down. 1 and 1 plus the square root of 2. What I want you to know, anytime that you have a radical or an imaginary root, and there's only one written, then you automatically know that there are multiple roots available. Let me just give you an example. Suppose that we had this as my roots. Let's say we had x equals 1, and let's say we had 3i. And these are the two roots that were written down, and the instructions were exactly the same as what we're looking at here. Give me the cubic equation from where these roots came from. Well, cubic means that there are 3 roots. Or if I had quartic, if it was a 4th power, I mean there would be 4 roots. But I only have 2 roots. And so what the problem is basically telling you is that you should remember that when you have an imaginary root or when you have a radical root, the imaginaries and the radicals always come in pairs. Write that down. They always come in pairs. So if I had something like what you see on the screen right now, x equals 1 and 3i, automatically, without having to think about it, I know that negative 3i is also a root. Just the same way as you see in the bottom down here. If I did not have this one, if I had 1 plus the square root of 2, automatically I know that I have to have that negative square root of 2 as well. Because when you take the square root of something, that's how we get our imaginaries or our other radicals. We're beginning to, at the end of the problem, we would take the square root and we would get plus or minus some answer. Remember that if you're missing one of your imaginaries or one of your radicals, always remember to add that back into the problem before you complete it. Otherwise, when you go to multiply everything back together, it's going to be really ugly, and you're going to have lots of radicals left and lots of i's left over. You shouldn't have any of those. As you'll see in this problem, all of your imaginaries or all of your radical signs should disappear. So let's go through this one. The first part is to go ahead and rewrite it as factors. Now, organization is very important here. Being very deliberate and being very concise with your work is going to be really helpful to seeing how this works out. So before I reveal the next part, we just brought x minus 1, x minus this factor, and I'm leaving this as one kind of in parentheses, and I'll show you why in a little bit, and then x minus this whole thing. So I don't have to worry about 3 parts and how it distributes. Leave it simple. So the next part, we're going to go down, and what I've done is I've taken the first part, I'm leaving it alone. This is another rule, so you might want to write this down too. Whenever you have radicals or imaginaries in roots like this, you have to multiply those common parts together. So imaginaries go together, and then radicals go together. Otherwise, it gets really nasty. So I've really done FOIL with this part, but being very careful when I have the last 2 pieces. So watch. X times x is going to give me x squared. That's the first term. The outer term is going to be x here times this whole part. Since it's negative and x is positive, I'm going to get a negative sign. So negative x times 1 minus the square root of 2. I do not multiply that together yet. Then I do the inside parts, which is going to be this part, which is negative, and this part is positive, so I know I'm going to have a minus sign here, a negative sign. It's going to be 1 plus 2, or 1 plus the square root of 2 times x, just like that. Don't multiply it together yet. And then the last part is negative times negative, which is going to give me a positive. And then I just write these 2 parts down just like I would as I'm going to FOIL. And I haven't done that part yet, and we'll do that part in just a minute. And so what you get is this big, long equation, but it's not really that complicated once you take it apart. So I've tried to give you the indication FOIL to indicate which parts came from where. As you can see that as we looked at it from above. Now, what I'm going to do is, at this point, I'm going to distribute here, making sure to keep my signs correct. And then I'm going to go ahead and FOIL this part together. It's kind of like it's just like it looks. There is a shortcut to this one. These 2 are called conjugates because you have the same exact values for A and B. However, you have 1 plus, 1 minus. This is like the difference of squares. If I were to multiply these two things together, what's going to happen is the first terms will stay. The inner and outer terms are going to be opposite signs. You're going to get positive square root of 2 and negative square root of 2, so they're going to simply cancel out. And then you're going to have negative square root of 2 times positive square root of 2. And so you'll end up with a minus 2. So the shortcut to multiplying things like this is just a squared minus b squared. It's the difference of squares. And so once I do that, I would have 1 minus, it would be technically square root of 2 squared, or just 2. So I'd have 1 minus 2. I've got that written down for you so you didn't have to just believe me a word. And I'll show that in just a minute. Let's kind of take this one step at a time. As you go through this part, I went ahead and distributed here and wrote it down right there. I collected like terms with the x. I left this part separate because I wanted to make sure that you saw that this, in fact, did cancel out. You have x squared root of 2 and minus x squared root of 2. Here again, just confirmation that my radicals did separate and cancel each other out. So I don't have any radicals left. And so, I think you can follow me from there. I'm keeping that x minus 1 out front, and then I went ahead and just distributed through to get my final result. And this is the little multiplication for these two parts here. That's FOIL. So, and then if you simplify that, the 2 cancel out. That ends up being this way. So if I just did square that, I get 1. If I square root of 2, I get 2, and it's always a subtraction in the middle. So 1 minus 2 would give me negative 1. That's where this number comes from. And then I just distribute to get my final result. A lot of algebra, not hard, just a little bit. You have to be organized. You have to be very careful about your signs. There's lots of places that you can mess up on that. I recommend you going back through that, look through that until you are comfortable with the way that algebra follows. Okay, so let's talk about a couple of new things. So what we're going to do is I'm going to give you a little tutorial on max and mins and lots of other stuff with the calculator. Now, we're not always going to use the calculator for certain things, but some things there are things that we can't do to get accurate other than using a calculator. So, this is actually, I've chosen 2 of your homework problems to kind of just explore this with you. We've talked about a lot of this that we're going to get to today, but there's a lot of things that we haven't talked about yet. And so, pay attention. So if we look at number 17 in your books, if you have your books, it's in section 2.3. We are on page 193. You do not have to turn in your books, but that's where we are. So number 17 has f of x equals x minus 1 times x plus 2 times x plus 3. The instructions tell me to graph this in a window that allows me to see all the roots and all of its extrema. What it wants me to do is to define or to write out the end behavior using limits. As x approaches, blah, 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 f of x goes to. So, which is what we've already discussed. But at this point, I want to really talk to you about using max and the min feature in your calculator. So, if you haven't already, as I'm just kind of introducing this, I want you to go ahead and type this into into Y1 in your calculator. So as you get that in, you'll be able to follow along with me. If you don't have a calculator but you want to look on with someone, please move your desk or slide around so that you can see the calculators. And so if you graph this one, the picture you see is what you see on the right side of the screen. It looks like a traditional cubic equation, which we had 3 roots. It's a cubic. It's x cubed. No big deal. Looks just like I'd expect it to. I can see a 0 at -3, at -2, and +1. Exactly, if I had written this as roots, that's exactly what I would have. 1, -2, -3, as you can see from here. What it wants us to do eventually, the question is to write out the end behavior. And of course, if you can see, it's going down here, it's going up there. We'll get to that in a minute. So, I hope you've actually got that typed into your calculator so far. What we're going to do is we're going to find the minimums and maximums. So here you can see we have a local max or a relative maximum. And then down at the bottom here you can see we have a relative minimum. We don't have an actual absolute anything because these graphs go up forever and it's going to go down forever. So I don't have any absolutes, or I don't have any global values that are at just the maximum or the minimum. All right, here's the function or the instructions for finding min or max. If you'll press second, trace, or calculate, same button, and look at number 3 and 4. Now you have to be in graph mode. Well, you don't have to be, but hopefully you are looking at the graph and you want to find the minimum or maximum. So here's how you do it. You're going to press second, trace, and number 3 or number 4. I believe that I'm finding the minimum first. So let me clear that. So I've got a couple of screenshots that I want to show you, and then I'm going to kind of I want to go through it with you. So when you first find the minimum value, it's going to ask you for a left bound, it's going to ask you for a right bound, and then a guess, and then you'll be able to find your minimum values. And here I found the minimum, and here I found the maximum. And you can see that here and here. And I'm not just tracing it and getting it close. Don't ever do that. If you just trace the feature and think, oh, well, my cursor is right there at the top of the graph, not actually. It might look that way, but this is a specific decimal. You would never want to simply guess at it. So let's go to the calculator and let's follow along and see if we can get this to graph. So I'm going to go ahead and deactivate my first one because I want to keep that in the equation, or keep it on my calculator. Since that's the one working, I'm going to hit enter. If you've already typed it in, you're good. Then I'm going to hit, since I had moved my graph earlier, I had zoomed in, I don't want to keep that zoom. I'm going to go back to my standard graph. So rather than pressing graph, I'm going to hit zoom 6 and reset my graph so that it will look like that. And so I want to find this max. And so second, trace. I'm going to go down to, we'll do maximum. I'm going to scroll. The calculator is going to ask you 3 questions. It's going to say left bound, right bound, and guess. So what it's asking us to do is to give it a place to look for a maximum value. So it says, give me a left endpoint. So I want to get just to the left, and I'm talking about x values. I want to get just to the left of the maximum value here. So I'm going to press enter. And then I'm going to go just past the max. So there's the max. Go past it just a little bit. And then I'm going to press enter again. Now you've got these two vertical lines on my screen. You may not have these same screens. Okay, but what it's doing is it's getting 2 different values. So within that range, when you choose your left bound and right bound, it's going to look for a high point because we're looking for max. So I'm going to get close to it. It's asking me to guess for it. You can hit enter. And there's my maximum value, negative 2.54 and 0.7 or 0.88, I guess. And so you can see that over here. You can see where we looked at it, and we got the same values this way. The minimum value would be the exact same thing. I'm not going to go through that because I think you can do it, but you'd go and choose 3, and I would go to the left. So you go over here to the left side, choose a point, go to the right side, choose a point, and then go back in the middle and choose a point. And you get the idea. And in the interest of just finding mins and maxes, you would find those values. You can check yours here if you check that. Minimum and maximum feature. There's the minimum, left and right endpoint, and then guess, and the same thing for the maximum. To answer the question, it asks us for the end behavior. And so we have 4 pictures of the graph, technically. What we needed to know was end behavior of the graph. Where is it going up and down, and what's happening as x goes out to the infinity. So as we go out this direction to positive infinity, what's happening to my x value or my y value? So that's this part. That's this section. As x goes to the right side, that's keyword positive infinity. As x goes to the right side of my graph, what's happening to x? Well, x is going up, 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 up. Never going to stop going positive direction. So f of x goes to positive infinity. As x goes to the left side, as it goes to negative infinity, my graph is going down, down, down. So we would just identify that with negative infinity. This is basically what we would call a limit It's telling you a range of values, and it's telling you what this approaches. The arrow means as it goes to this spot, what is the value approaching? And so this would be how you would answer. And we'd already talked about this, but just wanted to make sure that you got that. One more example. Okay. This is number 19. If you have your calculators out, I want you to go ahead and type that into your calculator. We're going to go ahead and fully analyze this one. I know the instructions don't say that, but for right now, you don't have to do this in your homework. But tomorrow, we will have a quiz. The second half of class, I'll have a kind of a question and answer review session. But basically, this is what you're going to need to be able to do. Be able to look at a graph, to analyze the whole thing, and maybe do kind of what we did earlier with, if I gave you the roots, can you give me back the actual equation of the polynomial? All right, so number 19, f of x equals negative x cubed plus 4x squared plus 31x minus 70. We're going to graph this one, and so you can see here, this is the graph. It's a pretty nice graph, but it doesn't look like this to start with. So what I want to do is, here's another kind of mini tutorial. I want to be able to graph this, and I want to show you how can you get your window to look nice, because the automatic features here don't really work. You can hit zoom, and you can go zoom out, and you can do all kinds of things. It's not going to really get you where you want to be. So if I hit, let me reset my zoom to what it starts off with, everybody's going to see. So you have this huge, huge graph that goes down, and then it goes back up, then it goes back down, but all the important parts, other than the zeros, which look like to be whole numbers from what I'm seeing, it's not really on my screen. So I can kind of tell you the end behavior maybe, but I really would like to have a better view of this. And so what we're going to do, I'm going to teach you how to zoom. So you press zoom, and the first thing you want to try is just zoom out, right? Maybe you zoom out one time and you're like, oh, that's much better. So we're going to hit zoom and then 3. And it doesn't do anything because it's asking you, where would you like me to center when I zoom out? So since my cursor is right at 0, 0, this kind of looks like it's in the middle of my graph. I'm not really going to mess with that. But if you move the cursor, then whatever point you pick, that's where it's going to be centered on when you zoom out. So I'm just going to hit enter, and it zooms out right on the middle of the origin. It's going to regraph it, and I'm thinking, that's a little bit better, but it's getting squished because I have all this extra space on the x-axis that I really don't want to have. So rather than zooming out again, and it's just going to look the same, and it's going to get even skinnier and squished, we're going to go to our window. You might need to watch this part again. Okay, to do the window, well, let me tell you what I'm thinking. I need to go higher, and I need to go lower, so I need to go more y value, and I need to go to more negative y values, but I don't need to go all these positive and negative x values. So I'm going to go back in. Since my original function was okay, I'm going to go back and reset my window. The original x was negative 10, positive 10. I'm going to reset those. Because originally that part was okay. I could see left and right. It was the up and down part that I couldn't really tell. And so since negative 40 is not okay, I'm going to go ahead. Let's change that to negative 100. That's a good jump. Maybe we can get all of it in at that point. And I'm going to change to positive 100. I don't know that it's symmetric. And so by looking at the picture, my original picture, I'm thinking it's probably not symmetric because it doesn't pass through the origin. And so I'm going to go ahead, I'm going to hit graph. Don't hit zoom anything at this point because it will reset your window. Okay, so it still needs to go down some more. The up is okay. So I can see the bottom. I might need to get that on the particular screen because if I'm going to have to find the minimum, it needs to be on the screen. So we're going to go back to our window. Since I need to go further down, that's a y-axis problem. So minimum, I need to change that. Let's go to negative 125. And sometimes you're just going to have to play and trial and error this kind of thing, and you'll get better at it as you go. So now hit graph again and see if this gets everything in the picture. And there we go. Now, that takes practice. That takes a little bit of recognizing what the problem is. It takes a little bit of recognizing, well, how far should I go? The only way that I can teach you that is to show you what happens and give you ideas, and then that you begin to play around with that yourself. It's not random. You have a good educated guess on how to do that. So look at the problem and just kind of pick and choose. And sometimes I may have gone too far. I'll go back in and say maybe I didn't need to go to 100 on the positive y. I could go back and let's say 75 or that. But I can see everything I need to see here. And so you can see that perfectly right here. And that's exactly what I had set up here. You can see all the nice features. You can see the end behaviors happening. You can see the minimums. You can see the maximums. Nothing else I need. I can also see the zeros, which zeros are a very important part of analyzing a graph, which we haven't really discussed yet, but that's coming up next. What happens when you have an equation like this that does not factor, although this one I think does factor, but sometimes you're going to have some that are not factorable, and we're going to have to figure out, or maybe it's a fourth or fifth powered ones. We're going to talk about all that in the upcoming days. So let's go ahead and analyze this graph. Remember, these are the 8 steps to analyzing a graph, and we'll add in one more thing about zeros later on. Domain, this is a polynomial. Remember, I told you polynomials for domain are all real numbers. The range, it goes up and down forever, all real numbers. Okay, it's continuous. It has no breaks. It doesn't have an asymptote, or it doesn't have a hole. It doesn't have any stops. I can draw the entire graph without picking up my pencil. Increasing and decreasing. Now here, this is important. This is the part where you really want to be able to work your calculator and do it so that you can find these points. Because without these points, I can't do the minimum or maximum. Or I can't do the increasing and decreasing. Increasing, and you can see from here, let's look at this graph. I'm over here, and I'm going down until I get to this minimum value. So from negative infinity all the way to some number right in here, 2 point something, I'm headed down. For maximum, or for the middle part, it's headed upwards. So from this minimum all the way to this maximum, somewhere at negative 2 point infinity, all the way over to this section right here, I'm going to be going up. And then from this point to positive infinity, I'm headed down. Remember, it's as if you're walking along the curve. What would you say is terms of increasing or decreasing? If you're headed down, that would be decreasing. Headed up, that's increasing, and so forth. So let's look over here. For increasing, I went ahead and I used my minimum and maximum functions in the calculator, and I found the minimum value to be negative 2.15 and negative 108.22. The maximum 4.813 and 60.37 or so. Those two things. Notice which variable I used for the increasing and decreasing. I didn't pay any attention to the y value. The question was, where on the x-axis do you go up? Where do you go down? So in terms of the increasing, or in terms of the function. From my increasing interval goes from here to here. So on the x-axis, that's negative 2.15 to 4.18. That's going from this point, the minimum, all the way up to the maximum at that point. Decreasing, you have 2 decreasing intervals. That's the left part and the far right part. And so negative infinity to negative 2.15, and then 4.18 to positive infinity. All right. This has neither in terms of symmetry, and I kind of put that down here. To check for odd and even symmetry, what we're looking at is I'm going to plug in negative x to my original function. So if you go back up top, I replaced all the x's with negative x. You cannot trust a number on this one. So don't always say, oh, I'm just going to plug in negative 1. That does not always work. Okay? Be careful. So negative x, negative x, negative. I replaced every x that I had with negative x. I'm going to go ahead and simplify that, and I want to look at the signs of what results. So you can look at it this way. We have an opposite sign change from the positive x. It was originally negative. Now it's positive. Here it's positive and positive. So automatically, I can tell you that it's neither. Because with odd symmetry, every sign is backwards. So here's the backwards one. This is positive. This is negative. This one should have been negative. This one was opposite. And again, here, not opposite. Even symmetry has all the signs exactly the same. So when I plug in negative x, it doesn't change anything at all. But when you plug in for odd symmetry, you expect to see every single sign flip over. Now there is a quick and easy shortcut to this problem to know that it's neither automatically without really looking at it, and it's located right here. This is technically the y-intercept, but whenever you have a constant term, it will not be odd. Okay, maybe even, but I know that it's not going to be even because my degree is odd here. Okay, if it's an even function, it's going to have to be even. Your degree has to be even. So this could have been odd or could have been neither, but because we have a constant term, it's not. It's going to be neither, because when I plug in x, this sign's not going to change at all, no matter what I try. So since it can't be even, it's going to be neither for that matter. We're going to take this a little further. And so relative minimums, relative maximum. You can see that here. We obviously don't have any absolute minimums or maximum because the graph goes up and down forever in both directions. But we do have two pieces where it is minimum and maximum values. And you can see that. We found that earlier by the calculator. And I showed you those and just put those in a point form. Remember, you must give x and y for each one. Number 7. Do we have any asymptotes? Not in this problem. Remember, asymptotes only show up with fractions, with rational functions, and we'll get to those later. End behavior. This was the actual question of the day for this particular problem. It says, as f of x, we'll read it this way. As x goes to positive infinity, so as x goes to the right side, the graph is headed down, so it's negative infinity. As x goes to negative infinity, as x goes out to the left side, what's happening to y? It's going up, or the graph is going up. So you would say it goes to positive infinity. And this is a full analyzation other than zeros, which we'll get to later. We've analyzed that particular graph. What I want you to do at this point, I want you to grab your books. You can, if you need to rewatch some of this, please speak up, and you can rewind it and you can watch whatever parts you need. I do want you to recognize that this will be available on the website. You're probably watching it from my website. But also you can, if you go into chapter 1, this is chapter 2, but in chapter 1, there are some tutorials about increasing and decreasing and asymptotes that you may find very valuable in terms of analyzing graphs. If those two things are kind of sketchy for you, I suggest that you take a few minutes, they're not very long, and watch how to use increasing and decreasing. Is a very short video. I think most of you have a good grasp on that, but just in case. If asymptotes and these things, we haven't really done a lot with asymptotes yet, but if rational functions, and that's kind of funky, if you can't remember all three sections, remember we have vertical asymptotes, horizontal, and slanted asymptotes. I take a pretty in-depth look at how to find each one of those, and you can go back and make sure to watch that if you don't remember asymptotes. So your homework is on page 193. It will be problems number 17 through 28. And I've already done 2, and that's all. I've already done 2 of them for you. But actually, it's really just talking about in behavior. Not much else. So this one actually is nice. But what I want you to do for practice, I want you to pick 2 of those examples, and I want you to analyze the whole thing, kind of like what we did here, so that tomorrow you'll have a good idea of what's going on. Also, homework problems that I assigned, this is technically prior. I've already assigned this one. But on page 194, we looked at numbers 53 to 56. And of course, I did 2 of those for you today in the video above. Those are the other ones that we talked about, taking the function, the roots, and going backwards, or the zeros and going backwards to give me the equation. Practice those as well. If you haven't already done those, take a little bit and to work through those. I didn't get a chance to go over that with you, so I'd like for you to practice that one. So for the remainder of the period, I would like for you to get your books out. I don't mind that you work in groups, and I want you to work on your homework. Remember, on 2 of these problems, and it can't be 19 because I did that one for you, I want you to work out a full analyzation of one of these, of 2 of the graphs with you. If you have any questions, please feel free to email me. I will be accessible by email whenever you get a chance. And then I will see you tomorrow.